In this part, we want to solve fourth problem of IMO also. Similar problem from other IMO problems. Inequality here. We need to know weighted AMGM, and I will tell you these ideas concerning small examples, AMGM, telescoping rule, which is useful for IMO 2023, problem number 4, and homogenization, that is important. You need for this problem of IMO 2020, and you need also weighted AMGM for that problem. In some problem, you need to know when equality holds. You should find that. And there are some homeworks, 4 other homeworks that are useful for this idea when equality holds, and so much important this idea. And there are around 100 homeworks related to this problem. If you want to know them or want to learn more ideas, you can send message to my WhatsApp number in the description and comments. So let's start first this problem. Before that, we will use considering small example, this one, AMGM we want to use, but we start with considering. At first we don't know AMGM useful or what ideas are useful. We use a small example, then we find. And also I should tell you telescoping rule. If you don't know telescoping rule, let me tell you one problem with that. If someone says 1 times 1 factorial plus 2 times 2 factorial plus, for example, 100 times 100 factorial is what? Pause the video and try this problem first on your own. For solving this problem, I say that k times k factorial equal to k plus 1 factorial minus k factorial. Okay? You can easily say that they are equal. Why? Because if you factor from k factorial, it will be k plus 1 minus 1, which is k factorial times k. Now, I know 1 times 1 factorial, if I use this formula, is 2 factorial minus 1 factorial. 2 times 2 factorial is 3 factorial minus 2 factorial. 3 times 3 factorial is 4 factorial minus 3 factorial. And if we continue up to 100 times 100 factorial equal to 101 factorial minus 100 factorial, and then you can cancel. It will be what? 101 factorial minus 1 factorial. This action that you've seen here, we call it telescoping sum or rule. We have also telescoping product. It is similar to that. Now, I told you telescoping rule is what? Now, this part concerning small example and AMGM. So let me tell you first the inequality that you should know. It's maximum of, for example, suppose there are n variables. Let me tell you, I want to tell you QM, AM, GM, HM in this part. If you have x1 to xn, that they are positive, maximum of xi is greater than equal QM. QM is what? Square root of x1 squared to xn squared over n greater than equal am, which is x1 to xn over n, greater than equal gm, which is nth root of x1 to xn, greater than equal harmonic mean n over 1 over x1 to 1 over xn, greater than equal minimum xi. And also I will tell you weighted AMGM is what. So now we are ready to solve our main problem, this IMO problem. Okay, it says let x1, x2 to x2023 be pairwise different positive real numbers such that an equal to this, n equal to square root of x1 to xn times 1 over x1 to 1 over xn, and it says is an integer for every n equal to 1, 2 to 2023. Prove that a 2023 is at least 30, 34. Okay. So I've told you AMGM, all these things are what, and also equality holds for any two of them. Equality holds when all of them should be equal. x1 equal to x2 equal to xn. Now let's consider this one here. We use a small example. We solved also problem 1 of this IMO. For that problem also we've used a small example. A1 is what? Square root of x1 times 1 over x1, which is 1. A2 is what? Is the square root of x1 plus x2 times 1 over x1 plus 1 over x2. And the problem says AI are integers, okay? So here, if we multiply this x1 times 1 over x1 is 1, x2 times 1 over x2 is 1, plus x1 over x2 plus x2 over x1. Now, it says they are different, pairwise different. By AMGM, we know that x1 over x2 plus x2 over x1 is greater than equal 2 times product of them. Product of them is 1. So it will be 2. But we know it cannot be 2 because equality holds when these two things should be equal. Equality holds when x1 over x2 equal to x2 over x1. If we cross multiply, x1 squared equal to x2 squared. And we are analyzing the problem. The problem says they are positive real number and pairwise different. So here, because they are positive, x1, x2 are positive, we conclude that x1 should be equal to x2, and that's a contradiction. So we conclude that x1 over x2 plus x2 over x1 is strictly greater than 2 because equality cannot hold. Now, we conclude what? It is greater than 1 plus 1 is 2 plus 2 because this part is greater than 2. So it is greater than square root of 4, which is 2. So, and we know a2 is integer. Because a2 is integer and a2 is greater than 2, we've concluded that a2 is at least 3. Okay. Now let's check a3 by this definition. a3 again is, we can say something. By this rule, x1 plus x2 plus x3 1 over x1 plus 1 over x2 plus 1 over x3. Let's consider this one. Also here, you can use Cauchy-Schwarz, or if you don't want to use that, we know what. I told you these inequalities. Let me find it. Harmonic mean, geometric mean. Let's find. Okay. Here. Look, from if we consider AM and HM. So x1 plus x2, if we cross multiply xn or multiply by this denominator, both denominator 1 over x1 to 1 over xn, it is greater than equal, you multiply by n times this. Greater than equal n squared. By what? By am hm. Okay, so here we can say what? We can say it is greater than equal square root of, we proved by am hm. Also, you can prove with Cauchy-Schwarz, but with AMHM also is possible. If you multiply, it will be what? N squared. Here, 3 squared is 3. But equality we said holds when x1, x2, x3 equal in AMHM. And we know they are different numbers. So, because they are different, xi are different, we conclude equality cannot hold a3 greater than 3. So a3 is at least 4. If we use this approach, an is what is square root of x1 plus x2 to xn times 1 over x1 to 1 over xn, and it is at least square root of n squared, which is n, and we know equality holds when xi's are equal. Here by what? By amh. So xi are different. So we conclude an is at least n plus 1. But the problem says what? The problem says prove that an is at least, for example, a 2023, we prove is at least 2024, but it's 3034. So let's see, we should find a better rate. Let's see how can we reach 3034. If we check an, we proved n plus 1, and look here, we can see in this form we can use recursive sequence because we have x1 to xn minus 1 and here. So it is equivalent to somehow we can say, for example, an equal to an, or let's say an plus 1, for example, is at least an plus 1. But I want to say what? I want to find, for example, an plus t, suppose. I want to see if I prove t equal to what? Then I can prove a 2023 is at least 3034. For which t we can reach that? So I say a 2023. Let me first move it here. From this part, I know that it is equivalent that an plus 1 minus an is greater than equal to. So a 2023 minus a 2022 is at least t. Now a 2022 minus a 2021 is at least t again. A 2021 minus a 2020 is at least t again. Up to a2 minus a1 is at least t. Now, if we add all these things, a1 is what is 1. So we conclude a 2023. It is similar telescoping rule I've told you. At least 2022t plus 1. We take negative 1 to right side. And we want this part equal to 3034. So 2022t should be equal to 3033 if we subtract 1 from both sides. So t equal to what? T equal to 3033 over 2022. If we divide both numerator and denominator by 1011, it will be 3 over 2. So I want to prove that an plus 1 minus an is at least 3 over 2. So because it is fraction, if I want to change it to, let me tell you. So we can try to prove this, or also we can say an plus 2 minus an equal to an plus 2 minus an plus 1 plus, again by telescoping rule, an plus 1 minus an if you want to change it to integer. This part is at least 3 over 2, 3 over 2, at least 3. So the thing we should prove is, if we prove an plus 2 minus an is at least 3, the problem will be solved. Now let's write an plus 2. An plus 2 is what? By the definition, we know it is x1 plus x2 to xn plus xn plus 1 plus xn plus 2 times 1 over x1 plus 1 over x2 to 1 over xn plus 1 over xn plus 1 plus 1 over xn plus. We like to get rid of this square. So I say an plus 1, 2 squared equal to this part. Let me copy. Equal to this part. Now, here we say if we multiply this part by this part, it will be an squared by definition of an. An squared plus x1 to xn times 1 over xn plus 1 plus 1 over xn plus 2 plus this part 1 over x1 plus 1 over x2 to 1 over xn times xn plus 1 plus xn plus 2. So look, this times this times this part, this times this part, and this times this part. Okay, what is left here? Plus xn plus 1 times xn plus 1 is 1. Xn plus 1 over xn plus 2. Xn plus 2 over xn plus 1 plus xn plus 2 over times 1 over xn plus 2 is 1. Okay. Now, we know it is equivalent that an, because they are integers, if we prove an plus 2 minus an is greater than 2, it will be solved. Okay. And it is equivalent because we raised to the power of 2, we can take it to right side, an plus 2. And because both sides are positive, an plus 2 squared, we should prove y is greater than an squared plus 4an plus 4. Okay? Now, we have an squared here. We have also 2 here. Okay? And by AMGM, we've proved similar to this part. Here, for x1, x2, this part we prove it is greater than 2. Again, by similar way, by AMGM, we can say it is greater than 2. So we can say it is an squared greater than 2 plus 1 plus 1, 4. Only we should prove that it is greater than equal 4an. Let's see why. It is greater than an squared plus, let's consider this part. Proceed. Okay. And let me minimize it a bit. And it is greater than 2, so 2 plus 1 plus 1, it is greater than 4. So as you can see, we have an squared, we have 4, an squared 4. We need to only prove that 4an. If we prove this part is at least 4an, let me tell you which part, this part. If I prove this part is at least 4an, the problem will be solved. For these problems, it's good to work a bit on sentence, a bit on assumptions. Now, let's work on the pink part, x1 to xn, 1 over xn plus 1 plus 1 over xn plus 2, plus 1 over x1 to 1 over xn times xn plus 1 plus xn plus 2. I want to prove it is at least 4an because here we have strictly greater than. Because an is what? Product of this times this, but we have plus here. So we use AMGM and we change it to plus. It will be greater than equal 2 times square root of this part, x1 to xn times this one will be an squared times 1 over xn plus 1 plus 1 over xn plus 2 times xn plus 1 plus xn plus 2. Now, if we prove that it is greater than equal 4an, the problem will be solved. Now, I divide 4 by these 2, it will be 2. I divide an inside square root, an squared, an is positive. So I should prove this square root 1 over xn plus 1 plus 1 over xn plus 2. Again, by AMHM, as we said, or Cauchy-Schwarz, we can say it is greater than, also we can say it's strictly greater than square root of 2 squared, which is what? Which is 2. So we proved this. So this part has been proved. And which part we wanted to prove? This part. So there were question marks. All these things have been proved. So we proved this problem completely. Okay. Now we work on telescoping rule. We work on AMGM. Also we worked on, let me say, QM, AMGM, HM. We worked also on AMHM. We worked on considering small example. Homogenization is left, and when equality holds, weighted AMGM. So let's try this IMO problem. Okay, for solving this problem of IMO, I want to tell you first weighted AMGM is what, then homogenization is what, then we can solve this problem. These are two techniques. Weighted AM, especially homogenization. Weighted AMGM is this. For example, xi, we have x1 to xn, and non-negative real numbers, wi are non-negative real numbers, sum of them, w equal to w to wn, is positive. Then we have this inequality. And I want to say it is general form of AMGM. Why? If we consider wi equal to 1, then let's see what happens. x1 plus x2 to xn. W will be what? 1 to n ones. All of them are 1. W1 plus W2 to Wn. N ones, it will be n greater than equal nth root of x1 to the 1, x2 to the 1, 2, x. It will be exactly our AMGM for this special case. So this is general form of AMGM, especially here. Look, because it says A, B, C, D are real numbers and we have them in the power. So we can use AMGM. The next idea, homogenization, is what? For example, suppose x, y, z are positive real numbers and x plus y plus z equal to 3. We want to prove this. Homogenization is a technique. It's what? It's only one example. The left side, the degree is 2. X, y, y, z, all of them. But right side, the degree is 0. So we use this equality to raise both sides to the same degree. I say x plus y plus z, I raise it to the power of 2. Now, the degree here is 2. But because x plus y plus z is 3, 3 squared is 9. So I should divide it by 3. Now, both sides have same degree and also 3 equal to this one. Now, I want to prove this. So I multiply it by both sides by 3, 3xy plus 3yz plus 3zx is less than or equal. I raise this to the power of 2. It will be x squared plus y squared plus z squared plus 2xy plus 2xz plus 2yz. Then I subtract 2xy, 2xz, 2yz from both sides. It will be xy plus yz plus zx. Y is less than or equal x squared plus y squared plus z squared. So here we can prove it with AMGM. We can take all things to one side and change it to square of some terms, or we can say by AMGM we know x squared plus y squared over 2 is greater than or equal xy. X squared plus z squared by AMGM for two variables. X squared plus z squared over 2 is greater than or equal xz, and y squared plus z squared over 2 is greater than or equal yz. And if we add all these inequalities, this part will be proved, so this part. So we call this idea that raise both sides to the same power homogenization. Now we are ready to solve this problem. Let me copy this problem. Okay, so for this part, I want to use AMGM. The most important inequalities are AMGM, I can say QM, AMGM, HM, we said in this video, and also Cauchy-Schwarz. So here, let's say how can we use AMGM? We have A to the A, B to the B, C to the C to the C, D to the D. So if we write it, A to the A, B to the B, C to the C, D to the D. Square root of A plus B plus C plus D by this definition. Less than or equal, we can say what? Here, less than or equal A to the A, x1, w1 is A times A squared plus B squared plus C squared plus D squared. Over what? W was sum of them, W1 to Wn. A, B, C, D. A plus B plus C plus D. We know A plus B plus C plus D equal to 1. So it is equal, we've concluded, and this index is 1. So we've concluded that A to the A, B to the B, C to the C, and D to the D is less than or equal A squared plus B squared plus C squared plus D squared. So if we prove this part times this is less than 1, the problem will be solved. So now I want to prove why A squared plus B squared plus C squared plus D squared times A plus 2B plus 3C plus 4D, why this part is less than 1. And we know what? We know A is greater than equal B, greater than equal C, greater than equal D, greater than 0. And we know also A plus B plus C plus D equal to 1. Okay, so here I want to prove this. I use homogenization. We know A plus B plus C plus D is 1. I want to raise to same power. So I consider this part, the degree is 2 plus 1, 3. So I want to reach degree 3. So I add a plus b plus c plus d to the power of 3. I want to prove this. Now here, I try to consider different parts. I say, okay, let's see, can we prove a squared plus a plus 2b plus 3c plus 4d. So let's first see these terms are what? A cubed plus b cubed plus c cubed plus 3a squared b and so on plus abc. It will be 6abc and so on. So here, if you want to see how we consider all of them, if you want to consider, one way to check is this. Consider all of them, replace all of them with 1 to see number of terms equal or not. 4 cubed, 64. Here, how many terms are there? 4. Here, how many terms are there if we replace all of them with 1? It's 6 ABC, 4 choose 3. 4 times 6, 24. Here it was 64. Here it is what? A squared b. 4 times 3, 12. 12 times 3, 36. 36 plus 4, 40 plus 24, 64. It is a way to check have we considered all terms. If you had question about this or other things, as I said before, or want to learn more background ideas, feel free to send message to my WhatsApp number in the description and comments. Okay, so here I want to cover these two parts. I want to say the left side is less than or equal this part, so this part is positive, so it will be strictly greater than that. Here, if I want to consider first a squared, I factor from all terms that have a squared. It will be a plus 3b plus 3c plus 3d. I want to prove this. For b, I want to say a plus 2b plus 3c plus 4d. Again, if I factor from b squared in these two parts, it will be b squared 3a plus b plus 3c plus 3d. Next part is c squared times a plus 2b plus 3c plus 4d less than or equal c squared 3a plus 3b plus c plus 3d, and d squared a plus 2b plus 3c plus 4d. It's less than or equal. If we factor again from d squared, it will be 3a plus 3b plus 3c plus d. So if you prove all these four inequalities, the problem will be solved. Now, let's focus first on, let me add all these things here. Let me minimize them a bit. Now, let's see the first one is equivalent to what? We cancel a squared, they are positive. By assumption of the problem, we cancel a, we cancel 3c, 2b, 3b on right side, b on left side, 40 minus b should be greater than equal d. We know a, b, c, d are like this in decreasing order. So b is greater than equal d. So it will be correct. This one. We cancel b squared. We cancel 3c, 3c. We cancel, let's see, 4d here. We have 3d here. We have d on left side. We have considered this. What about 2bb? We have b here. What about 3aa, 2a? We know a is greater than equal b, a greater than equal d, so 2a greater than equal b and d, so it is correct. Third one, again, we cancel c squared, we cancel here 2b, 3c, so if we cancel 3cc here, we have 2c. If we cancel 4d, 3d, we have d here, y is less than or equal. a3, a2a, so we consider this 2b, 3b, b. We know b is greater than equal d, this one, 2a greater than equal to c. Because a is greater than equal b, greater than equal c, greater than equal d. This part is also correct. This part, if we cancel d squared, we can cancel 3c. Here, 3b, d. Okay, so 4d, on left side we have d. Y is less than or equal. 3b, 2b, on right side we have b. 3a minus a, 2a. Okay, and 4d minus d, 3d. So we know d is less than or equal b, 2d less than or equal 2a, because d is less than or equal b, less than or equal a. So this inequality again will be correct. Let me completely explain here why d is less than or equal b, d less than or equal a. So 2d less than or equal 2a. So if we add 3d is less than or equal b plus 2a. So here we proved all these terms. So this part is less than or equal this part. And we have some other positive terms because a, b, c, d are positive. So this part is strictly greater than this. So it will be correct. And because it is correct, this part will be correct. So in this problem, you've learned weighted AMGM and homogenization. Homogenization is so much useful, so much useful. Also, for example, in this problem of PMO, Philippine Mathematical Olympiad national level 2022, you need to use also homogenization. Try to do this problem as homework. I released the solution of this in my previous videos. And also, as I said before, if you want to learn all important ideas in inequalities and other things, feel free to send message to my WhatsApp number in the description and comments. Also, let me tell you for this part, what should we do? I will solve one of them for you to learn this topic. This topic is, I told you homogenization, weighted AMGM, only one idea was left when equality holds. We have also other ideas. For other ideas, if you want to learn, as I said before, feel free to send message to my WhatsApp number in the description and comments. This part when equality holds so much, so much, so much important and useful. Why? When you want to find good coefficients. So let me explain this for you here. For this problem, we can understand when they are, we guess that. We can check some answer. We guess that when they are equal, it's minimum. Okay, when they are equal means what? A equal to B equal to C equal to 1/2. So S will be equal to what? 1/2 plus 1/2 plus 1/2, 3/2 plus 1 over 1/2, 2 plus 2 plus 2, 6. So it will be 15 over 2. Okay. I want to say it is minimal. Now I want to use AMGM. So for this part, for this inequality, I want to use AMGM. I know that A plus 1 over A. If I want to use AMGM in inequality, in the case that we have equality, it is 1/2, but it is 2. So I know that equality holds for AMGM and they are equal. So if I want to find put coefficient, I should divide it by 4. Why? Because look, in equality, A is 1/2, 1 over A is 2. So if I want to reach equal case, I should consider 1 over 2 equal to 2 over 4. Okay, then they are equal. So I use AMGM like this. So A plus 1/4 A, 1 over 4 times A is greater than equal. If you use AMGM 2 times, A times 1 over 4A, we cancel. It will be 1/2 2 times square root of 1 over 4 is 2 times 1/2. It is equal to 1. B plus 1 over 4b similarly is greater than equal 1. C plus 1 over 4c is greater than equal 1. So we proved what? We proved that a plus b plus c, if we add, plus 1 over 4a plus 1 over 4b plus 1 over 4c is greater than equal 3. Now, what is left from S? 1 over 4, 3 over 4. So we should prove 3 over 4a plus 3 over 4b plus, 3 over 4 times 1 over a, which is this, 3 over 4b plus 3 over 4c, greater than equal 3 plus what? Reach 15 over 2, we want to prove 15 over 2 is what? Is 3 plus, let's check, 6, 9 over 2. I want to prove why it is greater than equal 9 over 2, because look, it is what is 6 over 2. If I prove this, the problem will be solved. Now I divide both sides by 3, so it will be 3. I multiply both sides by 2. It will be 2, 2, 2. Then I multiply both sides by 2, so I should prove 1 over a plus 1 over b plus 1 over c, why it is greater than equal. 2 times 3, 6. Okay? And now by assumption, we know what we know for ABC. We know a plus b plus c is less than or equal. A plus b plus c is less than or equal 3 over 2. Okay, now I know that a plus b plus c by AMHM, 1 over a plus 1 over b plus 1 over c, by AMHM is greater than equal 9. So I know what? I know that a plus b plus c is less than or equal 3 over 2. So it will be 3 over 2 times 1 over a plus 1 over b plus 1 over c. So we can conclude 1 over a plus 1 over b plus 1 over c, we multiply both sides by 2 over 3. 2 over 3 times 9, which is what? 3. 3, 6. So we've proved this inequality, so the problem has been solved. But how could we understand that we should consider this coefficient 1 over 4 to reach the answer? By the case that equality holds when what? Okay, by this idea. So I've told you this one, and you can solve these 4 problems. I solved one of them, other 3 problems, and a lot of other homeworks by using the case that when equality holds and find corresponding coefficients. Okay, so in this video I've told you a lot of ideas. We solved this problem of IMO, we solved this problem of IMO. I left this problem as homework, this problem of PMO, because it can be solved with the same idea. I told you 3 other homeworks and a lot of ideas here. 4 homeworks, I solved one of them, and I've showed you the idea that how you consider when equality holds and how can we find coefficients. There are some other ideas in inequalities and also other topics in algebra like functions, polynomials, identities, and also other topics like geometry, number theory, combinatorics. If you want to learn important ideas in these topics and solve more problems, learning background ideas, generalizing idea, and because background ideas are repeated every year. If you want to learn those ideas, as I said before, feel free, send message to my WhatsApp number in the description comments. Okay, thanks.